Uh, Good evening, guys. In this video, I'm going to explain the simple program related to merge sort method and the various functions which we are going to have to create in order to implement this sorting method. But please understand that in this video, I'm not going to discuss the logic behind the merge sort. I think I expect or I assume that you already know that thing, and in this video I'm only going to discuss the code that we are going to have to implement. So first of all, I'm going to use C to write this code, and I'm going to save this file as merge sort .c. And the first thing which we're going to do is use the preprocessor directive and include the header file as usual. And now we'll create the main function first. So here we go, and in the main function we'll declare an integer and we'll declare an array a, and in this array we're already going to pass the values which we are going to store. We can also take the values from the user, but let's not do that. Let's, for the sake of simplicity, in order to understand the code, assign the values just right here. So I'm going to assign various values here. So let's keep it simple. I'm going to use 2-digit numbers so that we don't get confused, and the digits at the 1th and 10th place are going to be the same. So here we go. And so yes, as you can see, there are 11 numbers which I have assigned in this array, and the indexing is going to start from 0 and end at 10. So with that done, with that declaration done, I'm going to start a loop. So the I variable I had declared was to run this loop and initialize this I integer at 0, and obviously I is going to be less than or equal to the maximum index. So but since we are starting from 0, we don't have to worry about that thing. So here goes the loop, and at the end we'll also make the various functions which we are going to need. But in this loop, the first thing which is going to happen is we're going to print the array which in its original form. So I'm going to use the format string %d because it's the array is of the integer type, and AI. So this will print all the elements from 11 to 55 because the loop is running from the index 0 to 10. And done with this. After that, I'm going to call a function which we are yet to declare and define, but let's do it here. So the function is merge sort. So underscore here, the merge sort function, and in this function I'm going to pass the value a and 11. So this function is basically going to sort this array for us, but let's define it later. And once the function has been called, we'll again print the array. So I'll tell you why I did this. The format string and the array AI. So but before that, before we print this array, we need this array below the array which was printed before this, the previous array. So for that, I'm going to do a simple thing. I'm going to print this /n, and this will like leave one line for us. So this is very simple stuff. And another thing which we're going to take care of is I'm going to copy this for loop, because in order to print the array again, we need to run another loop. So no changes there, the same loop we're going to run, and this is it. This is the main function right here. But as you can see, we need to define this merge sort function here. So let's write the coding for the merge sort function. So void merge sort, and I'm going to pass an array, and I'm going to need an integer n. So let's define this. So we need another integer which I'm going to declare inside the scope of this function L, and I'm going to initialize it to 1. So what is this L? So as you know, in merge sort function we like divide a list into a various number of lists, and then we sort them individually. We regroup them into pairs, and then we regroup them into lists of double the size. But L basically signifies the number of elements in each of those sub arrays or sub lists which form the pairs. So we have to initialize it to 1, and it will increase with time. And for this sorting we need another array, and I'm going to name it array B, and it's going to have a length of 11. And inside this merge sort function we're going to start a while loop. So the condition is going to be as long as L, and again L is the total number of elements in each sub list, as long as this is less than the integer n. And what's n, you might ask? N is the total number of elements in the array. As long as this condition holds, what's going to happen? We're going to call another function which is going to be named as merge pass, and inside this function we're going to pass the values a, n, and l, b. So no need to get confused. A is just our array, n is the total number of elements, l is the number of elements in each sub array, and b is the second array which we just declared. And then we're going to call this function again twice. So if you know the logic behind merge sort, you will know why we call this function twice, because first we sort it into array B from A, and then back to A from B. So why do we do this? Because we need to regroup these singular sublists which we divide the original array into. So that's why we have to do this. So now I'm going to pass the values B, the array n. Now L is going to be multiplied with 2. So if you know the logic behind merge sort, you know why we multiplied this by 2, because this time we are going to have pairs of sublists, and each of these pairs is going to have 2 elements. So that's why we multiplied it by 2. And now back to A. And after that we just multiplied, point to be noted, we just multiplied L by 2. The value of L itself wasn't changed, but now it's going to be changed, and it's going to become 4 times, because now the sublists, each of them is going to have 4 elements. So this is our merge sort function over there. But now we have another function which we haven't defined yet, and it's the merge pass function. So we need to define this function in order to execute it. So let's define it. Void merge pass. Inside this function I'm going to pass as formal arguments some things like an array of the int type, int a, an integer n, an integer l, and another array of the int type. So with that done, let's write the code. So I'm going to declare another integer j and another integer lb, which stands for lower bound. So what's the lower bound? In any sublist or subarray, the index of the first element, this is going to be our lower bound. So we need more integers, more variables of the integer type q, s, and r. So we'll see what these mean and why we use this. So let's assign value into q. So q is going to be equal to n, which is the total number of elements in the array, divided by 2 times l. So l, we already know what this is. L is the total number of elements in each subarray. And what is q? So Q is the total number of array pairs to be merged, and it's quite simple that this is going to be equal to n divided by 2 times L, because L is the total number of pairs, and once double that value we have pairs here. In one pair there are 2 values, so once we double that and divide by the total number of elements in the array, we are going to have the total number of pairs which we have to merge. So this is Q, and now we have to assign value in S, and S is going to be equal to 2 times L into Q. So what is S? This question might arise, and let me tell you, S is the total number of elements in all pairs of arrays. Total number of elements in all pairs of arrays. So now what's the difference between S and N then? N is the total number of elements in the array, and S is the total number of elements in all pairs of arrays. So point to be noted, not all arrays are going to form pairs. Some of them are going to be left as residues, because you might have odd number of elements in an array. As the case is in front of us, we have 11 elements, and you can't form pairs from all of these elements, because if you divide 11 by 2, you're not going to get an integer. So we can have 5 pairs, and one sub array is going to be left. So S and N are pretty much different. So let me write this here so that we don't have any confusions. So with that done, we need to assign another variable R. So this R, now we know it's the residual value. So what is this thing? This is simply the sub-arrays which could not form pairs. Now why they couldn't form pairs? Because the total number of elements in the array which needed to be sorted was not an even number. So this is very simple. This is going to be equal to n minus s. So this is the difference between n and s, this R. So I'm gonna name it as residual elements. So with that done, now this merge pass, in this function we need to start a loop, and so a for loop is going to work for us and initialize this integer variable j to 0, and as long as this j is less than q. What's q? Q is the total number of array pairs to be merged. As long as it's less than q, the loop is going to run. Now here's the increment, and inside this loop we are going to assign lower bound first. Oh my god, what the hell happened? So here it is. So lower bound is going to be equal to 2 times j, which keeps changing as the loop runs, multiplied by L. Now what's L? L is the total number of elements in each subarray, which is also changing, by the way. This might seem as a never-ending inception, but we're going to pass another function which is going to be named as merge function, and it might seem tedious, but this is the last one. We're going to define this function outside, and then we are done with the merge sort. So but we're going to call the merge function, and inside the merge function I'm going to pass the actual arguments a, L, the lower bound. So a is the array, L is the total number of elements in each subarray, lower bound is the index of the first element of a subarray. And from this merge pass function we're going to again pass a, because from a, the array, we are creating a sorted one, and it's going to have the same L elements, but the lower bound, it's going to change and we need to add L to it. Now why do we need to add L to it? Because we need the next element, so that we can compare the next element in the merge function, so which we are going to define in moments. So here we pass b and lb. So why b? Because this is also going to be involved. We are like uh, changing the control from A to B, then B to A, and then again to A, so that we finally achieve a sorted array in the end. So with this, the for loop is going to end. So here the body of the for loop ends, but now we have some things which need to be done. We have the residue elements which need to be dealt with. So we're going to use a conditional statement if r less than equal to L. So which means if the number of residual elements is less than or equal to L. What's L? The total number of elements in each subarray. So what does that mean? It means that only one subarray is left. Only one subarray is left. So if that happens, then what? Then we're going to start another loop, assign j to 0, and as long as j is less than the number of residual elements, the loop is going to run. And what will this do? We need to simply pass the residual elements to the next array, and for that to happen, the elements of array 1 s plus j will lead us to the residual elements. We're simply going to assign this in the second array b, and same s plus j. So did I use uppercase letter for j? Yeah, that's a mistake here. I'm going to correct this. It's going to give an error later. So yes, very simple. And with that done, we have another situation that might arise, that the number of residual elements might not be just one. We can have a pair of two subarrays that will have different number of elements. So which means that what does that mean? It means we have a last pair of arrays left with unequal size. So what will we do then? You guessed it, we're going to call the merge function once again. So let's pass the actual arguments. A, so what's A? So we already know that the name of the array signifies the starting index of an array, and L is the, again, total number of elements in each subpair, and S, we already know this, total number of elements in all pairs of arrays, and then A again. Now R minus L, S plus L. So these things, once you go through the logic behind merge sort, you will understand these. So B and S. So with that done, our merge pass function has been defined. So one more thing, one more function which is yet to be defined is the merge function, and this is the basic core of this merge sort algorithm, because we divided the original array into subarrays and then we needed to merge them. Let's define this function, void merge, and as formal arguments I'm going to pass int a, an array of the integer type, int n1, and this int n1 signifies the total number of elements in this array, int index. So this is a variable which is going to change, and it signifies the element which we are dealing with at a time for the array A. And now we need another array to be passed as the formal argument, A. Now we have a B, another array, and int n2, which is the total number of elements of this array B, index 2, which is the element of the B array which we are dealing with at a time, and then another array of the integer type C. So array A gets merged to array B to fuse together into array C. So with array C we just need int index of this array. So the formal arguments are all set. Now in the body of the function we need to start a loop. So as long as n1 and n2 they're not 0, this loop runs, and inside the loop we need a conditional. If a index 1, what does that mean? The element of the array having index 1 is less than the element of the array B having index 2. Since we are sorting this into ascending order, so that's why we use the conditional like that. Unless mentioned, the sorting is always done into ascending order. So inside the conditional statement, if this holds, then in the C array we simply pass A because it's less than B. So A index 1. Done. And now we need to move to the next index for array C. Index, we're going to give it an increment for array C, and similarly for array A we also need an increment, and we need to decrease n1. So what is n1? It is the total number of elements. Since we already passed it into 6, so for the future comparisons we don't need this particular element which we pass into C. So we're going to decrease the total number of elements in this array. And so what if this condition doesn't hold? We have to think about this. So an else keyword is going to be used. So what do? We simply, A is not less than B, which automatically means B is less than A. So we pass B into C instead of A. So C index is going to be assigned this B element from the B array at index 2, and then the same thing which we are going to do, index given an increment and index 2 given an increment, and n2 will be decreased. Very simple. And this is the else, this is the okay, so this is where the loop ends. So let's mark it while loop ends. So but the thing is, what if n1 and n2 are not equal, right? What if n2 is 0 and n1 is not 0? And what if n1 is 0 and n2 is not 0? Then we need to separately define what is going to happen in that case. So we need to start another loop outside this while loop, while n1. So we don't need to write this all over again. Let's just copy it. So from here we're going to copy it. Oh my god, I'm lost. So here we go. It's the same thing all over again, and we need to separately define this for the second B1, sorry, B array B and n2. So let's copy this over here. What the hell happened? So let's save this program, and the overall program consists of 72 lines, and it has the main function. Let's go through it again, which calls the merge sort function, and the merge sort function itself calls the merge pass function. The merge pass function calls the merge function, and all of these functions have been defined. So you can write this code on your own, or you can copy it and then you can check the results. So now it's time to compile. It's going to have a lot of errors which I'm expecting, and we need to debug it obviously. So let's compile. Oh my god, unknown type. So here I made a mistake, I didn't specify the type. So let's do this. Error expected before this token. So yes, here I use the wrong bracket. So these things are quite common and inevitable. Errors are going to happen, but one must do is we need to debug. Undefined reference to printf. Where? Okay, so I forgot the f. How silly. And no errors now. And as you can see, this is the first original array here. This is the sorted array, and it's in ascending order, as you can see. So now you can modify this code. You can like take the values from the user, and then you can like add some text like this is the original array, this is the sorted array. So these things are optional, and this is the fundamental code for the merge sort. I hope you liked this video. If you liked it, leave a like, and if you didn't like it, leave a dislike. So for any queries, you can use the comment section. Okay, have a nice evening.